Now let's just move on further towards the new topic which is all related with this chapter, which is nothing but called as the surface area of a sphere. And in this particular topic we also will study about the surface area of a hemisphere, because a hemisphere is actually a half of that of a sphere. But before that, let us suppose if I'll ask you a question that what is a sphere? Is it just as same as that of a circle? First of all, we know that how we can able to form a circle. We know that circle is actually nothing but a collection of all those points that are lying on this particular plane in such a way that its a distance from a given fixed point is always the same. It is always the same. So when I'm just talking about the fixed point, it is nothing but called as the center of the circle. And if I'm just talking about the fixed distance, then it is nothing but called as the radius of this particular circle. So the question arises that whether a circle and a sphere, they are similar to each other. So let's just perform an activity. So let us suppose if I am just taking a circular disc and I'm just taking a thread or a string along its diameter and I'm just revolving it in such a manner. As you can see over here, the way it is revolving, I'm revolving this disc, this circular disc in such a manner. So it will form a special or a solid figure over here, which is nothing but a figure of this type, which is called as nothing but a sphere. So after revolving a particular circular disc along its diameter in such a way, the figure so formed is nothing but called as a sphere. So what is the definition of a sphere? The definition of a sphere is that it is nothing but a three-dimensional figure, a solid figure which is made up of all the points in the space which lie at a constant distance, called as the radius from a fixed point, which is nothing but called as the center of the sphere. So this is nothing but all about a sphere, that it is nothing but a three-dimensional figure. It is a three-dimensional figure, a solid figure. It do have a radius as well, it do have a center as well. Now there exists a special note which is all related with this sphere, which is that a sphere is like the surface of a ball. So if we are just comparing it with a ball, so it is actually like the surface of a ball. The word sphere is used for the solid whose surface is a sphere. So this is a special note which is all related with the sphere. Now let us suppose if I'm just talking about its surface area, because the topic is all about that surface area of a sphere. So actually the surface area of the sphere is nothing but 4 times as that of the area of the circle. Always remember that there is a relationship in between their areas, that the area of the sphere is actually nothing but or the surface area of the sphere is actually nothing but 4 times the area of the circle. And we know that the area of circle is nothing but pi r square, which makes the surface area of a sphere as nothing but 4 pi r square, where r is nothing but the radius of the sphere. So this is nothing but called as the surface area of the sphere, which is 4 pi r square. Now let us suppose if I'll cut the sphere along its diameter. Let us suppose if I'm just cutting this sphere, this three-dimensional solid figure along its diameter, then what kind of a figure should be obtained? So as you can see, if I'm just cutting it along its diameter, the figure so obtained is nothing but of this formation. So we'll have now the 2 halves of the sphere. So this 1 half is nothing but actually called as the hemisphere. This is nothing but called as the hemisphere. So what is the curved surface area of the hemisphere? It is nothing but half of that of the surface area of the sphere. So we know that the surface area of the sphere is 4 pi r square. So the curved surface area of the hemisphere would be half of that of the sphere, which is nothing but 2 pi r square. But if I'm just talking about the total surface area of the hemisphere, so it would be nothing but is equal to 3 pi r square. So how it is coming out to be 3 pi r square? Because if I'm just talking about the curved surface area, it means that I'm just talking about this particular surface area. This is nothing but called as the surface area. But when I'm just talking about the total, it means that we are also involving this particular circle as well. So the total surface area would be nothing but the curved surface area of the hemisphere plus the area of this particular circle, which is nothing but pi r square. So pi r square plus 2 pi r square is nothing but is equal to 3 pi r square, and this is nothing but the total surface area of the hemisphere. So this is all about the surface area of the sphere and the hemisphere. Now let's just do some of the problems that are all related with these.